So they would sanitize the room, they would sanitize the equipment, they would sanitize the floors. And the first thing the operators did was to come in the room, and as they opened the door sweep, it would contaminate the floor. People would walk through it, and over the course of the day, that contamination, just through movement in the room, would get up onto product contact surfaces. Back then, if there was a food contamination, it was very contained. They shipped product to Chicago, which was a big market, and if there was a contamination, it affected a small population. Now we ship products around the world, and so if somebody has a foodborne contamination, it can affect everybody.
There are two big things in the 3As. If the product touches the surface, it must be a product contact surface. And if it doesn't touch the surface, it must be a non-contact surface. I know I'm wrong, but why am I wrong? Food manufacturers and machine builders, they face a constant balancing act, trying to deliver safe, high-quality products, while also, of course, navigating some of all of these standards on hygienic design that we have. Misjudging a surface or overlooking a slight detail in the design can lead to contamination and, of course, costly recalls and damaging reputation. We've covered this in plenty episodes before this one, including the one with Bill Mahler on the legal side of contaminations. With the recent updates to the 3A standards, I think it makes really good sense to take a look at the requirements for hygienic food production again, to kind of revisit what's happened. And today, that's what we're going to talk about in Behind Clean Lines. I'm Mikkel Svold, and with me I have Gabe Miller, who is a 3A CCE, that is a certified conformative evaluator. That means that Gabe has spent his career inspecting equipment to certify it against the standards. And I would probably argue, seen firsthand, what these changes they can actually do to a food production. Welcome to you, Gabe.
Hi. Thanks, Mikkel. I appreciate you inviting me.
Joining us as well is Tue Skrubbeltrang from NGI. You're the commercial director at NGI. And what you're participating with is basically the insights from the food producers and the OEMs producing the machines. So you have I hope you have some of the hands-on knowledge on to implement some of these standards. Welcome to you too. And am I right?
Thank you very much, Mikkel. I sure hope that you're right, because we have approximately 5,000 customers around the world, mainly OEMs, with whom we regularly speak. So we get a lot of direct feedback from the companies actually manufacturing the production equipment for the food industry.
Perfect. I think let's just try and dive right into it, Gabe. Maybe you can take us through the 3A standards. They've just been updated. What has happened?
Okay. So for anybody that's not familiar, I'm going to just give a really brief background. The 3A standards have been in place now for almost 100 years. Okay, and they were developed because of food contaminations. The officials in the city of Chicago about 100 years ago were recognizing that children were getting sick and dying from foodborne contaminations. And so they developed these standards. And the standards have evolved over the years. Back then, everything was taken apart to be manually cleaned. They made pipelines out of glass. They didn't use the same materials that we have available today. So the standards have constantly been being revised to keep up with current technology, current practices, manufacturing methods, new ideas for making things, and of course, the scale of manufacturing and the automation that's going on now is completely different than it was 100 years ago, as everybody can imagine. Everything then was very manual, and now everything is very automated. And also, back then, if there was a food contamination, it was very contained. They shipped product to Chicago, which was a big market, and if there was a contamination, it affected a small population. Now we ship products around the world, And so if somebody has a foodborne contamination, it can affect everybody, both commercially and, of course, from a health standpoint. If anybody has followed any of the recalls that have occurred, both in Europe and the US and other countries, when there is an issue, it is very widespread because we manufacture products and send them everywhere. So the whole climate has changed in the food manufacturing process, and the standards have continued to evolve to keep up with that. Okay, so the general standards, this is now the third iteration of them. When the general standards were first developed, I happened to be the chair of the committee that developed them, and we had input. The 3A standards are developed by input from 3 groups. Why it's called 3A is 3 agencies. The regulatory bodies, which are the FDA and USDA inspectors, the equipment manufacturers, who are NGI and all the companies that manufacture the valves and the fittings and the tanks, and then the processors, the people who actually use the equipment. Those 3 groups of people now develop the standards in a collaboration, and all 3 parties have to agree to the standards in order for them to be adopted. So nobody is the gorilla in the room that can impose anything or create criteria that are not practical for the other groups. Okay, so
can you come up with an example where that has been the case?
Well, I'm going to say radii. Okay, so people who are manufacturing equipment don't want to be constricted very much in the radius in the corners because sometimes from a manufacturing standpoint, it's easier for them to make something that has a sharp corner. If you're welding 2 components together in an angle, okay, at a 90-degree angle, if it's a sharp angle, it is very difficult to clean. The larger the radius makes it easier to clean. And so the regulatory body wants it to be as large a radius as possible. Equipment manufacturers don't want to be constrained by that. And so we had to reach an agreement with all parties. And the end users, they don't care as long as it's cleanable and it doesn't cost too much and it meets the regulatory requirements. Okay? So everybody has a different perspective, but radius is a issue that we reach a compromise between all the parties about something that is practical to manufacture, but also cleanable and inspectable.
I want to turn to you two because when I look at the NGI product portfolio, I've never thought about it like this, but it has like an organic look to it. It looks like it has like organic shapes.
Yeah.
But I guess this is the reason that Gabe Miller just gave is you need the rounder edges.
Yeah,
we don't get marketing involved in designing things. It's from a standard standpoint, but it does. I never thought about that, but you're correct. Everything tends to be rounded. So I'm sorry.
What thoughts go into that process at NGI?
This is basically a hygienic feature. It's not really a design choice for the optics. It looks nice and it looks organic, as you say, Mikkel.
Yeah,
but it's really to achieve the best cleanability. The rounded corners make it easier for the surfaces to be self-draining. So that's basically why we do that. And these design criteria, which are defined by, among others, 3A, EHEDG, for instance, are very well known to us at NGI. Our entire design department know these in detail. And every time we design something, we, of course, commit ourselves to these design criteria to make sure we are always as hygienic as possible.
But is it harder to manufacture?
In some cases it is, but not necessarily. And this is actually a really important point. We try to also spread this message to many of our customers, the OEMs, because it is a well-known myth that hygienic equipment is more expensive to make than generic equipment. And this is not necessarily the truth. To some extent, it might be, but in many cases, if you design correctly from the beginning, it doesn't have to be more expensive to make, at least not necessarily. And that same goes for us. So if we do it correctly from the start, we can actually make something hygienic without it being too expensive.
I think it's also been very clear from earlier episodes talking to all kinds of people, exactly what you say. If you know it from the very beginning of a design process, it's not necessarily adding any cost. But on the flip side, if you try to retrofit hygienic design or try to retrofit components, it seems from earlier episodes at least that can be really costly. But anyway, I want to actually come back to the development in the 3A standards, because just 3 weeks ago, there was an update. Just if you were to break that down, Gabe, just in like easy chunks, what did that update do? The one that's very new.
Okay. So the update has not imposed any new significant criteria to the standards, okay, but it has clarified some of those criteria. The welds on surface finishes. The current or the previous standard had an ambiguity, the way that it was written, that two different people might interpret the criteria for surface finish on a weld in two different ways. And it became an issue a few times when a regulatory person said that doesn't meet the standards, and other people looked at it and said, well, it certainly does, because they're looking at different language in the same clause of the standard. So that was clarified to make sure to eliminate hopefully any ambiguity or misinterpretation of that particular clause. The radius in the corners of some seal joints, we have some very specific criteria around the different types of O-rings versus mechanical force seals and the radius that's required in the corners. And so we tried to clarify that language to make sure, again, that it was not misinterpreted. When somebody looked at it, they say, oh, that's not compliant with the standard. And somebody else says, no, it is. So we tried to clarify that. The other thing that we have added to the standard is a lot more materials that had not previously been listed specifically, especially around stainless steel or metal materials in the standard. We now have a whole host of tables of other type of materials. The general criteria for standards is everything has to be at least as corrosion resistant as 304 stainless. It's been around for 100 years. But there are many, many different applications that require different materials with greater corrosion resistant. Nowadays, most equipment in product contact is manufactured from 316L stainless steel. It's a more corrosion resistant material, but 304 is still the basic reference, okay? But there are also many applications where people need a material that has either higher corrosion resistance because of the environment of its use, or a harder material because it's like a piston on a filling machine, where 304 or 316 might be might not be suitable for a moving component. They also have other materials for different applications. And so the standard has expanded all of those tables to be able for a manufacturer to reference and find alternate materials that may suit their application without going through a lot of testing to decide if this is okay to use.
You know what? If I were an OEM, machine builder, every time I heard that there was about to, that the standards were about to be updated, I would be a little bit nervous, because you never know if you suddenly have to change something in your production. Is that something you meet?
That's a really good point, because, regulations always seem to they evolve to become more stringent over time. And we attempted to make sure we did not do that unless there was some compelling health reason. Just because if somebody were to say, you know what, I think a smoother surface would be better than the 32 microinch or zero 0.8 micron, it would be easier to clean. It would be more sanitary. Okay, well, that might be true, but there is no public health reason to try to change that particular criteria in the standard, so it has remained the same. We tried not to impose any new criteria in the general standard that would disenfranchise or require significant changes to current symbol holders.
And Tue Skrubbeltrang, at NGI and your partners, is that the same? Is that the same experience?
I'd say, to be honest, that unfortunately, when the design criteria for instance from 3A are updated, I think that unfortunately many of our customers, the OEMs, do not necessarily know about it. So this is of course something that Gabe and his colleagues work hard to change and promote, the fact that there are now updated or revised criteria. But I think in many cases, unfortunately, our customers are not necessarily that aware, and they might not see it until a customer specifically points it out to them that they need to comply in a different way than they've been doing so far.
Okay.
But I definitely agree, Gabe, in the way you guys do it, that you don't make changes just to be able to offer something new or improvements for the sake of improvement, if there isn't really a problem, because I think that's also the way to make sure the OEMs actually take notice when you have something relevant new to offer.
Yeah. So one other thing that has happened in the standards, we've also looked at newer technologies. Things have evolved. And so a few examples are for metal fabrication. Before, everything was made out of either cast material or solid material and machined. And now, of course, we have injection molding of metals. We have 3D printing of materials. And so we try to also allow for manufacturers to adopt some of the newer technologies as long as they met the fundamental criteria in the standards. It's got to be inspectable. It's got to be cleanable. It can't be porous. It can't be like a sponge that water can get into it, because that would leave openings for bacteria to contaminate surfaces. So we have added some language in there to allow for some of these newer technologies to be used, not creating an additional criteria for people, but providing them with a means of manufacturing equipment that might be better or less expensive or provide a better surface finish for something. And so that's also in the general standard, in the newest revision of the general standard.
Okay. I want to shift the conversation a little bit now, because we've talked about all the different standards, but you've also mentioned surfaces quite a few times. And what we talked about before turning on the microphones, last time we spoke, there are two big things in the 3A. So there's the product contact surfaces and there are non-product contact surfaces. And it seems to me such an easy thing to understand, right? If the product touches the surface, it must be a product contact surface. And if it doesn't touch the surface, it must be a non-contact surface. I know I'm wrong because we spoke about this before, but why am I wrong?
That is a really good question. And one of the things that we are constantly trying to educate people, and to refer to it before, that the OEMs, equipment manufacturers, or end users may not be familiar with the concept of what might be considered a product contact surface. So you're correct, obviously. Anything that comes in direct product contact is a product contact surface. That's a duh. Okay.
Yeah.
But
good job.
The other definition in the 3A standards is that it's the components, surfaces that are in contact with the product, or any surfaces from which liquids can drip, drain, or be drawn into product contact or in contact with the product contact surfaces of the packaging. Okay.
Wow.
So
that's like, I think we need to break that up just a little bit, because it sounds like a word puzzle.
Okay. So some of it is very simple. Okay.
Yeah.
Anything that can drip into the product is a product contact surface. If you think about a pipeline or even a sealing over the top of product, if it's got condensation on it that could drip into the container or onto the product, becomes a product contact surface unless it's shielded to prevent it from dripping into it. And we run into this primarily on filling machines all the time because the containers are coming down the line. They're on a conveyor belt. Okay. They have to go underneath the filling head. And so the pipeline that's carrying let's think yogurt. Okay. We're filling yogurt. The pipelines are very obvious. Okay. We can make them sanitary. But as that container is coming underneath the filling nozzle, any liquids on the filling head, which are going to be condensing because it's cold product, it will condense water. And I've actually watched a filling machine where liquids were dripping off the top of the filling machine into the containers. Okay. And so all those areas are considered product contact unless there is a shield put in place to make sure, think of an umbrella to keep water off of you. Okay. It's not much different. You're trying to keep anything from above from dripping into the containers or onto the product.
That also makes quite good sense, and it's not a direct, it's not directly understandable, but it's still kind of easy to acknowledge that yes, of course, this must also be clean, right? Must also be very hygienic, obviously.
Yeah. So
what are some of the edge cases?
Well, the other things are where a conveyor belt. Okay, let's just think about cheese that's on a conveyor belt. Okay, of course, the conveyor belt surface is a product contact surface because the cheese is sitting on it. Okay, but the conveyor belt also rolls around underneath itself. That's the way conveyor belts work. Okay, so anything that is a contaminant that's underneath or inside the conveyor is now going to drip onto the belt. And now the belt is going to roll around and the cheese is going to sit on it. So everything that's inside that conveyor, the rollers, the bottom of the conveyor, all become product contact surfaces because of the conveyor belt coming around to contact the product. So that is a real good edge situation that people are not aware of. And I've got some fantastic photos to show you how really badly things can go wrong when people are not paying attention to that issue. They don't think about it. And so that's probably the biggest edge situation that you have.
I know too that parts of NGI's product portfolio is the bearings. Can you try and put some words on how you've been thinking about this exact issue?
Yeah, well, our bearings are probably a good example because they are not, in many cases, they are not actually meant for to be placed directly in the product contact surface, but they are placed right next to the product contact surface. And when you transport food products, for instance, you cannot always 100% control where the product is. So on a conveyor, for instance, if you transport raw meats or something like that, they might flap around a little bit. It sounds disgusting, but that's how it is in real life, flapping meat. And this meat might actually come into contact with our bearings. But even more importantly, bearings are a dynamic part. It turns continuously during the day, and it has to be lubricated in order to work properly. And most bearings are lubricated many times a month to make sure that they are properly lubricated. And this lubrication has a tendency to leak from the product, from the bearing. And this is lubrication which might also spread to the product, for instance. And you cannot, it's really hard to control how that spreads and where it spreads to, even though the bearing is outside of the product area directly. It might still be that this lubrication can spread to the product.
That is a really good example. So in the standards, I'm actually not sure about the EHEDG standard, how they handle that. But in the 3A standard, lubricated bearings have to be separated from product contact surfaces by a minimum of 1 inch or 25.4 millimeters that is visible, so that if there is any leakage in the bearing, they can see it before it reaches over. And 1 inch is probably an arbitrary number because it was an even number many years ago. But it's a reasonable distance to require separation from a lubricated bearing from a product contact surface for the very reason you just pointed out.
I know we talked about also an edge case in our prepping to this podcast. You talked about something, was it in a doorway or something like that? Can you maybe dig up that example again? I that was very interesting.
Okay, so this is now the why our non-product contact surface is important. So the first thing that we talked about is what are product contact surfaces, and so that's actually fairly well defined if people understand it. But for equipment that is a non-product contact surface, people tend to regard it as much less important. And it's not obviously not as critical as those components in direct product contact. However, non-product contact surfaces also become very important because they can harbor contamination that migrates into the product. Okay. Microbes aren't very mobile. They don't swim, they don't fly. Okay, they ride. They ride on us, they ride on our equipment. And so the example that I told you about was in a meat processing plant that for a period of a year had a continuous contamination in their product, or high microbial content on their product contact surfaces for listeria. Okay, obviously a very serious organism. And they could not find it. They did a tremendous job of taking the equipment apart. They had tabletop surfaces for handling meat, okay, that were stainless steel, solid stainless steel. They cleaned it, they sanitized it. In the morning, it was completely sanitary, and by the end of the day, it was contaminated. And ultimately, what they found out was that the doorways coming into the room were hollow at the bottom. They did not have a seal to the inside. And so they would sanitize the room, they would sanitize the equipment, they would sanitize the floors. And the first thing the operators did was to come in the room, and as they opened the door sweep, it would contaminate the floor. People would walk through it. And over the course of the day, that contamination, just through movement in the room, would get up onto product contact surfaces. So
basically riding on other stuff. So riding on water droplets.
Riding on other things. People's shoes, people's clothing, the wheels. If you're bringing a cart into a room, if you think about it, the cart wheel is rolling. What's happening? The floors are a little wet. As it rolls, it slings that up into the air. And where does it land? Onto product contact surfaces. So the non-product contact surfaces, while the criteria in the standard is much more relaxed, those surfaces still have to be cleanable and inspectable to minimize the risk of cross-contamination between those areas and the product contact surfaces.
I don't know if you were involved in it, but back then, but I just wonder, how do you discover? How do you come to the conclusion? Oh, it must be the doorway. How do you discover that? Take the whole.
So I was not there when they were swabbing. Okay, so by the quality control people in the processor's plant, they would do swabbing of all the equipment before they started production in the morning, and they would also swab other surfaces. And I'm not sure how they happened to find it. I wasn't in the facility when they had that aha moment, when they realized this was the source of it. But somebody in swabbing figured out that this was the root cause of the problem.
And then you replace the doors.
And then you replace the doors. So,
Tue, you want to join in?
Tue, you want to talk about your equipment?
I always want to talk about my equipment, but actually not in this case. I was just going to add that probably this doorway was far away, probably many meters away from the product contact surface, but still it was a problem. And this just emphasizes why the equipment in its whole should be hygienically designed to avoid having these issues, which might lead to contamination. I think this emphasizes the importance of a proper hygienic design. And why should you follow the 3A guideline? It's because you want to have machinery with limited or even, you can never completely eliminate, but at least reduce to a minimum the contamination risk, but also improve the cleanability of the equipment, because cleanability also means commercial advantage. The machinery is cleaned every day, in some cases several times a day. So you spend a lot of resources cleaning the machinery. And if the machinery is as hygienically designed as possible, it's also easy to clean, and you can actually save money every day in the production.
Yeah, and I guess a good point here is also that production halts when it's cleaned, right? So the faster you can finish a cleaning cycle, the more production you can have running, or you can have it run.
That's a very good point. It reduces downtime also.
Yeah. If I can comment, one thing that Tue had said earlier, and also referencing the time for cleaning, people think purchasing managers don't get involved, unfortunately, in the sanitary design purchase. Okay, they think their job is to buy the cheapest equipment that they can get very often, and what they fail to understand too often is they pay for the equipment one time, and they're going to live with it for 30 years. And so if they put in equipment that's not easy to clean or easy to inspect or not sanitary, it may be less expensive when they put it in, but over the course of its use, it could become extremely expensive for them, either because it takes longer to clean or they have contamination issues that create these big problems.
Yeah, because one of my questions would be, why not just make everything super hygienic? Just like the entire factory. Just make it one big clean room. Why is that not a thing?
This is where my experience comes into hand, I think.
Yeah, I think maybe.
I get this feedback all the time, but I'm sure you do too, Gabe. But we of course, it's a matter of cost. Like I said, there is a myth that it's much more expensive to make hygienically optimized equipment, which is not necessarily the truth, but it might be that some of the details do make the equipment a little bit more expensive to produce. And of course, for the food manufacturer also to buy. But this is a one-time investment. You do that once, but you produce on the machine probably for at least 10 years, maybe even 30, as you said, Gabe. And the headaches of a suboptimal hygienic design are every day. So
I want to look a little bit into the future. What can we expect from the standards going forward? Do you expect the European standards, maybe even the UK standards? I know that they of course look alike, but the European standards and the US standards, the 3A standards, do you expect them to be more aligned in the future? Do you expect them to collaborate more?
Okay, so we do have a collaboration. We call it harmonization between EHEDG and 3A. Okay, I actually collaborate with EHEDG frequently. I do training for the EHEDG Central American conferences. I do training for them there. Okay, I know the people quite well. And in the 3A standards, we actually recognize some of the testing that's done at EHEDG as compliant with the 3A standards. When we talk about cleanability, CIP ability of equipment, they have a DOC 2 is one of their standards, and they do really good testing for pumps and valves and fittings and components. And if equipment meets EHEDG DOC 2, I consider it to be CIP-able. Okay, the seals are good. It's completely cleanable. They do an excellent job of that. Okay, so we harmonize with them in some cases. Some of our standards are actually parallel to each other. The surface finish is the same. The welding criteria, if you look at their welding standards to our welding standards, they're the same. Okay. And there are some things that won't change because they take a slightly different approach to it. So in 3A, we are prescriptive. We tell you, you have to have a certain radius. You have to have a certain radius, I guess is a big one. We establish the criteria. If they meet those criteria, we consider it to be sanitary. In EHEDG, they depend on testing. They say, okay, so you built it to be sanitary, but we have to test it. And they are more not prescriptive, but proscriptive. I don't know. They test to verify it. And so we recognize it, but it doesn't apply to all equipment. It's good for small components, but if you're making a filling machine or building a silo, well, you can't fill it up with a gel material and do the testing on it like that. We have other methods that we recognize as meeting the standards to verify that it's cleanable.
But would it be fair to say that if you comply with either of the standards, you should be more or less home safe in getting the certification across the pond as well?
Almost.
On either sides?
Almost. Okay. The only thing that becomes a little bit of a problem there is materials. The European regulations regarding toxic materials or food grade materials are different than the U.S. regulations, and I cannot tell you why. Okay. That's a regulatory issue. But the U.S. FDA regulations for accepting rubber or plastic materials are slightly different than those in Europe. Now, there are many manufacturers of rubber components that meet both. Okay, that's a perfect world. But in general, your statement is true. I tell end users, I said, I don't care which equipment you buy. If you buy 3A or EHEDG certified equipment, it makes no difference to me. As long as the materials comply with your regulations, it's going to be sanitary.
I think just our time is nearly up, but I want to ask you one last question, and I want to ask you first to on your wish list for sanitary standards going forward. Is there anything that comes to mind that you wish would change or would be added or would be, subtracted or yeah?
I think, to be honest, I think that's out of my area of expertise to challenge what the experts recommend. To if I'm being honest, but I think my prime wish for the future would be that everybody from the food industry, the OEMs and the brand owners, were more knowledgeable about the design criteria, because this would help all processes extremely. Every time you design a new piece of equipment, if you do it right from the start, it's much easier and the end result will become much better, and it will support food safety and commercial advantages much better than the current standard does, at least.
And Gabe, what about you? What's on your wish list?
On my wish list, actually, I'm going to echo what Tue just said, is knowledge for people to become familiar. When they start designing equipment, if they start off with sanitary design requirements as their first requirement and design around it, as Tue said before, it's not necessarily any more expensive to make a corner when they're machining it, whether you use a 0 radius or a 1/4 inch radius tool. Sometimes it's easier to make something with a radius than it is to make it a sharp corner if they just knew what they should do. I've gone in and looked at inspecting equipment, and people said, well, this is how we design it. Say, well, I look at it and say, if you didn't do that, it would be less expensive for you to make it, and it would meet the standard. You've done something that is now more difficult to clean, and it doesn't meet the criteria. So it goes back to knowledge for the people who are doing the design and for the people who are purchasing equipment to be aware of the standards and understanding the need for sanitary design as a first criteria instead of an afterthought.
So summing up, the need for knowledge on the standards and what's going on in the standards. And also, I'm also hearing the need for maybe, puncturing the myth of hygienic equipment being more expensive. I know that is the case in some cases, but I'm also hearing you say that it's not necessarily more expensive. Yeah. It's just a design choice.
It's different.
Yeah, it's just different.
It pays over time, at least, Mikkel, because as we spoke about, it's only the machine that's more expensive probably to purchase. But over time, the total value of ownership will be much better because it's easier to clean, you reduce risk, and you reduce the cleaning time and the cleaning costs.
I think let's end on that. Gabe Miller, Tue Skrubbeltrang, thank you so much for joining the show today. If you have any questions for either Gabe or for Tue or for me or for the rest of anyone that we've had on board this podcast throughout the episodes, do reach out to us on podcast@NGI-global.com. And you're going to get that again. So it's podcast@NGI-global.com. And we'll be at the other end of that trying to answer your questions. Or if you have someone you think could be interesting for us to talk to, let us know through that channel. We'll surely monitor that and hope to hear from you. I think with that, that's all I have to say for now. So yeah, thank you so much for listening.